game theory, which started at the beginning of section, it was section A. We covered game theory up until we got to the slide. So this video seeks to cover the other sections that we didn't cover in class together, mainly the standard deviation and expected return. Also, the capital stock is going to be addressed, the theory is going to be addressed in this video. So I will start with the calculation for your expected return. So in this particular situation, you are given the state of the economy. You're given the probability of occurrence of the states of the economy. There's a 40% chance that there's going to be an upswing, which is 0.4. There's a 40% chance that it's going to be a normal state of economy, 40%, and a downswing of 20%, which is up to 1. So we want to use the states of outcome to calculate the expected return. How you do that? You are given the states of the economy, the probability of investment, and the outcome. So in that particular case, it is straightforward. You just take the investment, multiply by the probability, you get 320. 600 multiplied by 40%, you get to 40. And 200 multiplied by 20%, you should get 40. And so you have to be careful. In some situations, they might give you that these are revenues. If these are revenues, they have to give you a percentage of how much profits are made. But in this particular case, this outcome is estimated to be your profits. So that's why you just take the outcome, multiply by the probability, you get your expectation, which is 600. So that's 600 you get by taking 320 plus 240 plus 400, which is 600. So that was the outcome of A. So you got column 2, which is the probability of occurrence, multiplied by the outcome, which gave you 320 to 40, 40, add them up, you get 600. So be careful with the wording of the questions. Sometimes those outcome might be sales, and you have to convert them first into profits before you calculate expectation. But in this particular example, the outcome of investment is assumed to be the profits. Hence, if you just take the profits and multiply it by the expected probability of occurrence, you get your expected profits. So you do the same for your B. You take the outcome of the investment, 1,000 times 40%, you get 4,000 pounds. 500 times 40%, you get 200. Then 300 times 20%, you get 60. Add them up, that is 660. So obviously in this particular case, project B is much more preferable than project A because it gives us a higher expected return. So this is the expected return. The next step will be to compute your standard deviation, which is a measure of risk. So how do you get your standard deviation? It is the profit minus the expected return that we calculated. In the previous slide, we calculated the expected return for A to be 600. So we would take the individual profits, 800 minus 600, 600 minus 600, 200 minus 600, square them and multiply by probability to get your deviation squared times probability, which are those figures. So if you take your profit minus your expected return, you square them up, you multiply by probability, you get that column of deviation squared times probability. And when you add that last column, you get 48,000 pounds, which is your variance. The standard deviation of that return will be square root of 48,000, which is 219.09. So this is the expected risk of that project, and standard deviation is a measure of the expected risk. You do the same for project B. We have your returns of 1,000, 500, and 300. You subtract each 1,000 minus 660, you square that up, multiply by the probability of occurrence of 0.4, you get 46 to 40. Take 500 pounds minus 660, square that up, multiply by 0.4, you get 10 to 40. Then finally, the last profit, which is 300 minus 660, square that up, multiplied by 0.2, you get 25,920. Then add that up, that gives you 82.4. If you make the standard deviation, it is 287.05. So based on standard deviation, you can see that the standard deviation for A, it is actually lower than the standard deviation of project B, which shows us that project A is much more less riskier than project B. So for you to come up to a conclusive answer, we'll have to compute another one, which is called the CV, which is the coefficient of variance. So this measures the standard deviation per unit of expected return. So you use it to compare the relative risk of two projects. So we're going to use for project A, expected return of 600 divided by the standard deviation of 219, while for project B, there's expected return of 660 divided by the standard deviation of 287. So if you compute your CV for project A, you discover that it is 0.37. So that is the standard deviation per unit of expected return. Then for project B, if you compute it to 87.05 divided by 660, 0.44. So this shows us that project A is less dispersion relative to its expected profit. So in this particular case, project A is less risky than project B because it is a lower CV. So you use CV as it shows you the standard deviation per expected pound of return. So in this particular case, project A would be less risky and we will choose it compared to project B. So master these calculations, how you compute your expected return, how you compute your standard deviation, and finally how you compute your CV, is they are quite important. And there is your formula for a CV. It is your standard deviation divided by your expected return. So master those ones. They're very, very important and they are used to compute our relative risk relative to the expected profit. Then we go on to the theory of capital. So this is explained in the pages of page 32 to 44 in your textbook. It shows us the rate of return when you sacrifice consumption for future level of consumption. So you can see there you have CE, which is current consumption. Then you have CP, which is future consumption. So as you can see there, if you sacrifice consumption of capital investment in T1 in order to gain a greater level in T2, you get a perpetual return of CP. So this is showing us if you sacrifice consumption now, how would that affect your investment in the next period? So you can see that if you sacrifice your consumption in T1, it's shown by CE, then you can increase your consumption to T2, which is CE. If you want to compute that perpetual return, it is given by CP, which is the perpetual rate of growth in the future. So in terms of a calculation, this looks like this. So you have your current level of consumption, which is 300. Then you have your future consumption. So you're going to take, the formula is CA minus CC minus 1. So you take 30 divided by 20, separate from 1. So 50%, that is your capital accumulation rate, which is R. Then for your perpetual rate, you take your CP, which is the one that you have, CP, which is 10,000, you divide by CC, multiply by 100 to get 50%. So important things to note are your current consumption is CC, consumption in time 2 is CE, then your perpetual is CP. So coming back to example, if you want to compute your return, you take your consumption in the next period, which is 30, divided by our CC, which is our current consumption in T1, 30 divided by 20 minus 1, which gives you times 100, which is 50%. Then for your perpetual rate, you would take the CP, which is given 10, divided by current consumption of 10, which gives you 50%. So your calculations there in terms of your return of capital accumulation and your perpetual rate of return there. Then as well, there are other technical possibilities for trading current consumption for future consumption. So remember that in here we're talking about a limited resource base in an economy. That is why this curve is concave. If you compare point A to point B, it is clear that at point B, the gain for future consumption is greater, because if you look at the vertical distance, which is shown by change in C1, it is greater than the change in C0. So the rate of return is positive, and also the slope is positive. The opposite is true in point A. Change in C1 is less than the change in CO, which tells you that the slope is negative in that particular point. Then we have the equilibrium rate of return for society. So this is determined by the difference curves. So we do have our equilibrium at a point E, where there's a highest possible indifference curve. So there's a tangent there, which is TU. It is tangent to the technical possibility curve. Then the rate of return R must be positive in order to motivate society to reduce current consumption. So this shows us that the slope of the curve is a negative slope, which is negative 1 plus R. So you can look at sections 37 to 39 in your slides. It shows how you move about that section, but the important thing to note in the slide is the slope is negative 1 plus R there, showing in a particular case, that is, you move up the case, you sacrifice less for future. In order, you sacrifice less, you sacrifice more units currently to gain less in future. That is what this negative slope is telling you. Initially, at point A, you're gaining more. Initially, in point B, you're sacrificing less currently to gain more in the future. There was a positive slope, but as you move up the curve, the slope becomes negative. Then we have this. We want to look at the impact of a decrease on tax, how that affects your capital stock. So we want to look at the trade-off between capital and labor. So our initial starting point is CA1, LA2. So that's our initial starting point. So the output there, it is at point A. So there's a decrease in tax. So there's a decrease in tax. So this decrease in tax reduces your marginal cost. So your marginal cost decreases from MC to MC dash, and this increases your. So now when you reduce that tax, it results in a greater output being produced from Q1 to Q2. And the first thing that's going to happen in there is that more labor is substituted for capital, i.e. we're going to have more capital and less labor. So we move on to point B in that Q1 curve, but we're now going to produce more output at Q2. Thus, we're going to invest more in capital, which moves us to our equilibrium point of CA2 and LA2. So this is the impact of a decrease in tax. Just to summarize it one more time, we start at an initial point where we have CA1 and LA2. We were producing an output of Q1 at that particular point. Then there's a decrease, a lower tax on capital stock. This shifts your MC from, in the diagram B, from MC to MC dash. Now we are producing a greater quantity at Q2. So at that particular point, more capital is substituted for labor. Hence, we move on to a higher point, which is B. As you can see in point B, on the initial Q2 care, on the initial A diagram, you can see at point B, now we have less labor and more capital at point B. And because of the increase in output, which is shown in B, this takes us to point C, which is your new equilibrium where you have capital at CA2 and LA2. So that is the impact of a decrease in tax. If tax is increased, the reverse will also happen there. So you can go through this section where you can look at the derivation of your rent and rental. You have this case study where you have your machine, which is of 100,000, and you're given that you have your rental rate R, then you're given the depreciation charge of 20%. So it will be 20 plus 5, which is 25. So machine, 25% of 500,000, which gives us 125,000. So that's the first part. We MRP, marginal rate of productivity, which is equal to your rental rate, which is 125. Then this other one is the opposite way, where we take our percentage, which is your 10%. You say 25,000 is equals to 10% of net income. Solve for net income and you get your answer of 250. So that's that calculation there. Then this is building up to calculation of net present value, which is a very, very important concept, which will be tested in your tests. You need to know that. So when we calculate the net present value, we'll be trying to discount future receipts. We want to see if we are gaining for a particular project. So if the NPV is negative, it shows us that the investment is greater than the returns that we're getting, and it is an indicating that the IRR is less than the benchmark discount rate. If the NPV is positive, it means the IRR of the project exceeds the benchmark discount rate. Now let's get into the question. So you have the question there, where the equipment is 500,000 and you have future capital streams of 150. These are inflows, 150, 175, 200, 210, 220. So what you need to do is to apply the discount rate. So the formula for a discount rate is 1 plus R. So what you're doing is you take 50,000, which is your 150,000, which is your first receipt, then you discount that. So when you're discounting that, you say 150 divided by 1 plus 12%. If you punch that in your calculator, you get 133,935. And that is to the power 1, because that is a receipt that we're anticipating to receive at 2015. When we go forward, for example, that receipt of 175, now it is divided by 1 plus 12% to the power 2, because we're anticipating that we are going to receive that receipt at the end of year 2, and your answer is 139,510. We go to the third year receipt of 2017, you take 200,000. This time we divide by 1 plus 12% to the power 3. Our answer becomes 142,360. Then you also take 210, now divided by 1 plus 12% to the power 4, which gives us 133,455. Then finally, the final receipt of 220. This time around, you divide it by 1 plus 12% to the power 5, which you get 124,828. So just to recap one more time, the first year, we discount 150, which we're going to receive in 2015. You take 150, you divide by 1 plus 12% to the power 1. Punch that in your calculator. You should get 133,935. Go to the second year, it's 175 divided by 1 plus 12% to the power 2, which you get 139,510. Then you go to the third year, which is 200,000 divided by 1 plus 12% to the power 3, which you will get 142,360. Then there is 210 divided by 1 plus 12% to the power 4, which you get 133,455. Then finally 220 divided by 1 plus 12% to the power 4, which you get 124,828. Add all those receipts, you get 674,088. Then you subtract from the initial cost, which is 50,000, and you get 174,088. So since your NPV is positive, it shows us that our IRR is greater than 12%, and thus this equipment should be purchased. So the important thing to note is how you discount. Like how I went through the discounting rate, you use that cost of capital, which the discount rate of 12% to discount. Once you know how to discount, it becomes easier. So practice this example, as it is a crucial example. You're going to get this kind of calculation in assessment 1, as well as the very first calculation that we did today, this one. So from this video, I would say the big two calculations are calculating your expected return, standard deviation, coefficient of variation, and being in a position to choose which investment is better, as well as coming back to our last calculation, which is calculating the NPV and computing and seeing our IRR is greater than cost of capital. Hope you found this video to be informative. Practice this concept, as these concepts are more important and they're going to be tested in your assessment 1. Happy studying. See you in our next session.